Hello and welcome to Paleocast. I'm Dr. Elsa Pancharoli, and today we'll be looking at a branch of the bushy hedgerow of life that I'm especially fond of, the mammals. In this episode, I'll talk to Professor Christine Janis about mammal paleontology and her career. Christine is one of the world's foremost experts in paleontology and mammalogy, author of hundreds of scientific papers and co-author of, among many others, the major textbook Vertebrate Life, which is used for university teaching around the world. With an undergraduate degree from Cambridge, PhD from Harvard, and having held positions at Oregon State University, the Chicago Field Museum, University of Chicago, Brown University, and most recently at the University of Bristol in her home country of the UK, Christine has had a long and distinguished career. I know her quite well because she was my master's supervisor. We studied the ankle bones of carnivorous mammals together, looking at how their shape relates to the animal's locomotion and ecology. And in fact, it was Christine who inculcated me into the world of mammal paleontology. She is a rigorous, critical thinker. She's generous with her expertise and dedicated to fostering the talent of students and early career researchers. Today, we'll be looking at some of the research Christine has been involved with, including hoofed mammals, sabre-toothed South American marsupials, and the giant kangaroos of Australia's recent fossil past. We'll be delving into the tricksy world of comparative anatomy to find out to what extent you can reliably use modern animals to learn about ancient fossil life. She'll also share some of her advice about what it takes to carry out research and how things have changed for researchers during her lifetime. So without further ado, let's meet Christine and talk mammals. So welcome to Paleocast, Christine.
Hello, Elsa.
Well, I'd like to start the episode off by asking you a little bit about yourself. So you've had a distinguished career and you've worked with lots of really big names in paleontology over the years. But I was wondering, how did you actually get started down this path? Did you always want to study fossils?
Well, I got started by my mother taking me to see Fantasia when I was 7.
Oh, wow. I love Fantasia.
And at that point, there was no big dinosaur culture like there is now. Mm. There was maybe, one book you could buy for dinosaurs, the Burien book, and I saved up my pocket money to buy that. From Selfridges, I used to keep going back to their bookstore and looking at it until I had enough money to buy it, I'm like just pressing buy on Amazon. And there wasn't much of a dinosaur culture at all then, very unlike now, but I really got into that. And then my dad did buy me a book that had some fossil mammals in it, and that really intrigued me because, of course, those aren't covered in Fantasia. And that's sort of how I got into it when I was really, really young. I didn't think there was any possibility of a career doing it because, again, not in those days, you didn't think of that. Not that there's really any more possibility now.
I'm not sure things have improved.
I think there is, but I always kept an interest in that. I really wanted initially to become a vet because I really liked animals.
Yeah.
And then I decided that I was more interested in sort of healthy animals than sick ones. And in science, medicine and veterinary stuff is very much a technology. Anyway, but at that point, you were always told that girls can't be vets anyway, Again, right. Very unlike now, where most of the vets are female. And it wasn't really until I got to university where I was able to study paleontology that I realized this is really what I'd been into all along. So there you go.
It's funny that you say you wanted to study living animals instead of sick ones, and then instead you've ended up studying dead ones.
But you don't have to do experiments on dead ones, or sort of poke them and annoy them, or they're already dead. They don't mind being poked. So that's better.
Well, you've attended some of the best universities in the world as a student and as a researcher. But I wondered, when you were a student, did you enjoy that experience? Were you a good student?
Yeah, I loved being a university student. I hated being a high school student. I was awful at school, and I didn't really start to try until the sixth form, because I didn't see any point to it. But it was only in the sixth form when I really got into biology. Of course, I had to do physics and chemistry, but I was lousy at them. But I ended up memorizing everything, so I got good grades for A-level, back when I had some brain cells left to do that sort of stuff. And then the university, it was all completely different. It was like I walked into a different world. And it all made sense. And I really enjoyed working hard and studying and everything there.
So you were mentioning there, as a young woman, that this sort of had an impact on what people thought that you might be able to do later on in life. So I think, a lot of people, especially young women, are lost from science in quite early stages of their careers, if they get into science at all. And it kind of makes the fact that you are now a professor of science in your sort of very, I don't want to put this in a nice way, you're a mature person who is still in science. And has, I wasn't going to put it like
I'm still quite immature, but I'm old.
But it makes your endurance sort of in the field, it's quite a rare thing. And obviously we hope things are changing now, but I wonder, how was it for you, going through your career as a young woman in science? Do you feel that your gender did affect your success and how people treated you?
Okay, well, I think I entered paleo at a very propitious time. I was part of when I went to grad school at Harvard, I was sort of part of a cohort in America of people who were quite a lot of women at that time, just starting up. I was a bit younger than someone like Kay Berensmeyer, a bit older than Blair Van Valkenburg. So in that time when there were a bunch of women starting to do things, and there were jobs. The universities were still sort of expanding, and they were looking for people to do teaching. It's so different now. They don't really care about how you can teach, only whether you can get money for them. At the time, they were all looking for women to go and do the teaching, and particularly in America with comparative anatomy being something that was a required subject for medical students, which is not anymore. And of course, it's not taught here at all. But I mean, back then it was a required subject in America. And so there were openings, there were job openings. None of us did, well, I did a postdoc, but only because I came back to Cambridge. But basically, people didn't do postdocs. They just went straight into teaching, into quite a heavy teaching load, because that was what the jobs were at the time. This whole thing about your role as a professor to run a big lab and get grant money, particularly in America, but more and more so here now as well, was not on the agenda at the time, which is good because I would have completely failed out that one. So I think now academia is seen more as a business. Your role as a professor is to get money for the university, basically, not to teach. Who does the teaching? I have no idea. Who has time for teaching when they're doing all this grant writing? I have no idea. I think it's not an optimal situation for the undergraduates, but there you go.
It does seem like an awful lot of time is dedicated to just obtaining money now, isn't it? That's very interesting to hear. You've spent quite a lot of your career in the States, haven't you?
Most of my adult career was in the States, yes. And I was lousy at getting research funds. I mean, thank goodness there was a time when to get tenure, what counted was the fact that I did publish and had a good teaching records, and getting a research grant wasn't so important. I mean, me and research funds, I tell people I'm the person who put the fun in unfundable. Basically, I mean, I've never been able to get funding. I mean, I've got like 3 grants in my entire life, and not big ones either. So that's I just don't. That is a skill I don't have, and it's a skill that's vital these days. So again, it was very different times when I went into the profession, and I don't know how I'd be able to do it now.
Well, a lot of your earliest papers focused particularly on hoofed mammals, didn't they? I think a lot of your work is really quite foundational to our understanding of things like their dentition and limb proportions and how morphology relates to functioning in grazing mammals. So I wondered if you could maybe tell us a little bit about hoofed mammals in general. I thought we'd start by chatting a bit about their taxonomy. So we're discussing Arthrodactyls and Perissodactyls. So could you tell us what the sort of characteristics are of those groups?
Goodness. Well, they're closely related, but it's not clear whether or not they're sister taxa. There's some debate about that. They basically arose, well, they are first seen in the fossil record in the Eocene, and they start off small and get bigger over time. And they're interesting because they're so highly derived. I actually realized that, my colleague Blair van Valkenburg, we were doing quite similar things at the same time, me on ungulates, her on carnivores. And when I turned much later in life to carnivores, they're so easy. They do all kinds of different things. Whereas ungulates are so derived, they have so modified their teeth for one kind of diet and their limbs for cursorial locomotion. There's not much variability among them compared to carnivores. Well, look, when you and I did that project on the carnivore Garcania, it was like, I just started to realize how much easier carnivores are to work on as a group. There are lots of living forms, and they're different in their behavior and different in their morphology. Whereas there's not a lot of difference among the young. Obviously, if you want to study, compare horses and rhinos, yes, they're different, but they're so different that you can't even start with them, So they're very, very highly derived. And in that way, they're hard to study because there's not much difference between them. There's not a lot of difference between a closed habitat animal that's a browser and an open habitat animal that's a grazer. Yes, there is a difference you can quantify, but it's nothing like comparing a tree-dwelling carnivore with a fast-running open plains-dwelling carnivore.
Well, I think there's so much interesting stuff there. I think maybe one thing we should go back to there then is you say there's not a great deal of difference between them. But what the main difference between, of course, Arthrodactyls and Perissodactyls is sort of classically described as being their odd-toed or even-toed. Right. But that's not quite true, is it? It's not really about how many toes, but more about where the sort of the weight bearing is that correct?
Yeah, yes. Where the axis of weight is passing through the foot. So when you lose digits, whether you end up with 4 or 2 toes or 3 or 1 toe. But actually, in many ways, horses are much, much more like Arthrodactyls than they are like other Perissodactyls in terms of how they've modified their limbs, how they've modified their skull and dentition, and everything else. They're very much convergent with Arthrodactyls, whereas tapirs and rhinos are quite different.
And what are the sort of mechanisms? Why have they lost extra digits and elongated their legs in this way?
Interesting question. And I'm still trying to find out. It's not just to do with running speed. It's to do with conservation of energy in locomotion. Okay. And I think the real reason, but I can't tell you why, rhinos, hippos and tapirs are off doing something else their own way. But certainly horses and then derived Arthrodactyls like camels and ruminants, they're carrying, between 20 and 40% of their body mass as gut and gut contents. And so to do anything more efficiently, and walk on their feet all day and moving around all day, they have to be more modified in what their limbs are doing than say, a carnivore. Because they are doing it with proportionally less muscle power for the amount of weight they're carrying. Right. And that's something that really is not ever featured in people thinking about these animals. I still really need to write up some work that my former grad student at Brown, Andy Clifford, did on this stuff and of reasons for being cursorial and becoming unguligrate, standing on tippy toe, as do horses and ruminants. Yeah, do it sometime, like right after laundry and cooking and shopping and tidying the house up, and I'll get around to that. Hopefully before I die sometime, because he had some very good ideas. He left academia, and we talked a little bit about getting back together and writing some of the stuff up better. But he published one good paper from his thesis, but not the whole of his thesis. But I don't think it matters. I think we can still go back to it. I think no one thinks of it in that way because people only think of ungulates as being fodder for carnivores. I think a lot of how we think about science and animals and science comes out of the tradition of Victorian English scholarship. And maybe they were studying beetles and moths, and on the weekend they go out and hunt on their horses with their dogs and stuff, hounds, and ungulates are things that run away and things to be run after and things to eat. They don't get much respect. I mean, that's what I wrote in the start of that arms race paper, that, think about the difference in the words asinine and leonine. People don't really have a lot of respect for ungulates in this culture unless they're unless they're huge males of some sort, When we talk about gentle herbivores, and what's gentle about a buffalo, So I think people always see their adaptations as being for speed, and I think speed is a byproduct of what they've done with their legs. I don't think that's why they make their legs that way. They make them because they're on their feet all day. They have to move around all day to eat. They have to be on their feet, and they have to carry that weight in an efficient fashion. And so they've sacrificed agility and flexibility with the limbs for just, not spending all their energy standing up and moving. But there's ideas like expressed occasion. I really need to sort of pull those together and write them up in a coherent fashion.
It's very interesting that these sorts of legacies that we have from a particular mindset from the past, we kind of all think to ourselves, oh well, we've moved on since then. But it's amazing how they do linger. And I see what you mean. Like, we don't really talk about herbivores in, well, maybe not a positive way, but we don't, nobody wants to be a donkey. Everybody wants to be a lion, as you point out. There's a kind of bias there, isn't there, in the way that we think about them and what they do and why they exist and how they're trying to exist. It's really interesting.
I think it's because they've been beasts of burden and prey animals you hunt. They're not seen as having their own agenda. And I think for me growing up, I was so into horses, and I actually wanted to leave school and become a riding instructor, and it was completely forbidden by my parents. Probably a good thing. And I always saw, I don't know, for me, the ungulates, were always, like I said, they were animals with their own agenda. And I think it's also part of the reason why I got into kangaroos, especially the Siberian kangaroos. They were sort of forgotten herbivores, thought to be stupid, and...
Oh, I definitely want to come back to talk about kangaroos in a moment, because there's a lot to talk about there. I guess one other thing I wanted to bring up about ungulates is you mentioned earlier about browsing and grazing, and of course how this relates to teeth. Could you maybe tell our listeners a little bit about, why it matters whether something browses or grazes, and what kind of effect that has on an animal's anatomy?
Right. Well, for a start, even before you think of the teeth, the stomachs of browsers and grazers are different in their basic form and function. I mean, you need different kinds of microorganisms and different kind of stomach structure for browsing and grazing. Well, certainly you do in ruminants, as we only have grazing horses today. It's hard to know about browsing horses, but I presume they did. So you can't just switch diets that easily. What I'm going to say is the diet you have is also linked to stomach and gut anatomy and physiology, as well as to how you process the food and obtain the food and process it with the teeth and stuff. And then grass traditionally has been thought of being something that's very abrasive and wears the teeth down. So you have to have these teeth that are hypsilon or torque round, which means that rather than just stopping at a sort of gum line, your teeth continue down into the jaw. And as they wear down, they sort of push up through the jaw, a bit like the lead in a mechanical pencil. But they are finite in length. You know, for a very old horse, it would just wear its teeth out completely. But it's probably not so much the grass itself that's causing the abrasion. It's the habit of eating the grass, of eating low to the ground, where you have to consume soil and grit along with the grass. And you can sort of see some support for that idea with things like the pronghorn in North America that only eats low-lying browse plants on the plains mainly, a bit of young grass too. But it has teeth that are as high crowned as a cow, basically, because it's having to consume other stuff along with the food. So, yes, grass has silica in it, and grass is probably more abrasive than browse material like soft leaves. But a lot of browse material is hard and woody as well. So I think a lot of it is how you're eating as much as what you're eating. So, but the thing is, if you have these highly hypsilon cheek teeth, then you've got to sort of restructure your whole skull to accommodate them. So you end up with this longer face and your eye further back in the skull, or other kinds of things that, you know, make that. I don't know. They just. I don't know if they limit what else you can do with your skull, but they certainly are derived things you have to do to your skull to accommodate the teeth.
Hmm. So it kind of answers that classic joke about the horse walking into the bar, flying a long face. Exactly. Well, because I eat grass with lots of dirt. Well, so let's move on to marsupials, because in recent years you've been doing, I think it would be fair to say, a lot more research on marsupials rather than ungulates.
Well, that's true. That's true, but I've been going back to fossil horses. I just got 2 big book chapters about to come out next year on fossil horses. So, I mean, part of the reason I didn't get into horse evolution when I was younger, which I really wanted to do, was that I'm about the same age as Bruce McFadden, and he was seen as the person who was doing horses, you know? Mm-hmm. So I was basically encouraged not to look at horse evolution because that was being done by somebody.
I see.
So only in my later life am I now gotten back to doing horses again.
Right. It's funny because I always think of you as being somebody who studies lots of horses, but I think that's because I also know you have horses and you have a real passion for them. So, yeah.
Well, in terms of phylogenetics and anatomy stuff, I did more on rumen and Arthrodactyls. Of course, my first paper was about horses, and they feature horses, but.
Well, let's have a chat now about marsupials. Okay. So I'd like to talk about one of your more sort of recent papers and other papers that you've had on the similar subjects. But one of your recent papers was about Thylacosemilus.
Oh, that thing.
Well, I thought before we talked about the paper itself and the research, I thought I would tell the listeners a little bit about what Thylacosemilus is.
Okay, go ahead.
So, I mean, I'm sure that all of the listeners have heard of saber-toothed cats. I'm using air quotes. You can't see me, but I'm using air quotes. And of course, they might not have heard about this particular one. So if you aren't familiar with Thylacosemilus, it looks like a cat superficially, but as Christine is no doubt about to tell us, it isn't actually a cat at all because it's part of the Metatherian branch of mammals. So that's the much larger group that includes marsupials. And the skull is really weird. It has this sort of huge inflated forehead that seems to push its eyes further apart. And it also has, of course, saber-tooth, gives it away. It has these long, elongated canine teeth. But unlike the classic saber-tooth that you might think of, like Smilodon, the bottom jaw of Thylacosemilus has these huge projections of bone that come downwards from the chin, and that's where the teeth sit when the jaw is closed. It's kind of almost like half of a scabbard for a dagger. So, and I'm assuming, maybe Christine, you can tell me that those phalanges are for preventing the teeth from being broken or something like that. I mean, basically, this is an animal that it would actually have looked quite strange to us today. And I don't think you would probably mistake it for a big cat if you saw one. But Christine, could you tell us a bit more about, when it lived and where, and then we can talk about your findings about it.
Okay, well, first comment is that a lot of saber-toothed cats and cat-like forms, other placentals, have those big projections of the lower jaw too. In fact, Smilodon is a bit unusual in not having them.
Particularly, I didn't know that.
Particularly this thing called Barbara-Felis. It's not a true cat, but it's cat-related. People think it looks very similar to Thylagus smilis. Actually, it doesn't, apart from that feature, but I'll come back to that in a second. Anyway, Thylagus smilis was a sparassodont. That's a branch of metatherians, not within marsupials. It's outside that clustering of modern extant marsupials. And they were the carnivorous forms in South America from the Paleocene to the Pliocene. And Thylagus smilis is sort of the last. It's in its own family. I think it's now been put into something. Never mind. It's its own family at least, and we have little sort of fragments of things that might be related. I think from the Miocene onwards. I would really have to go back and look this up. Sorry, but we don't have complete skulls of anything related to it until we find this animal. I mean, you have 2 or 3 skulls of it anyway, and it's from Argentina in the Pliocene, sort of before the exchange with North America, and it's about the size of a leopard. Mm-hmm. And it's not built like a cat. It's got plantigrade foot posture and quite a stiff back. It wouldn't have been a runner, or it does seem to have quite powerful forelimbs. But there are many ways in which it doesn't look like a saber-toothed cat. Well, for a start, it doesn't have any incisors. How can you
really?
How can you get meat off the bone if you've got those huge sabers that stop you? I mean, okay. So other saber-tooths have huge protruding incisors. This animal has none.
Right.
And and although you wouldn't expect it to have quite the same kinds of teeth, because you haven't got like the specialized carnassial teeth you see in the carnivorans, its teeth look really puny, and they're sort of marginally carnassial, but they're small for its size, and they wear blunt. And it's not that you can't get better, bigger carnassial-like teeth in other sparassodonts. You can. There are. It's something called prothylacynus and other animals like that. If you've been going to ask me about Thylagus smilis, I have looked at my paper again and got back on speed about this, because I basically wrote that paper with my colleagues and they said, right, that's my work done on this animal. Basically what happened is me and my colleague Borja Figueredo is in 2014 we were in the collections in the University of Nebraska, and for various reasons we weren't able to access the things we were there to see. But they did have this cast of the Thylagus smilis from Argentina, and the type specimen of which is in the Field Museum in Chicago. And we were looking at it and we were saying, okay, now this is a seriously weird animal. It is not doing. It's not a predator. It hasn't got any of the things that would make it a predator. And it hasn't even got a decent bolstered up back of the head with a large mastoid process for elevating and for doing a head strike. So we tried to write something about it, but we couldn't get it published. And then we got together with a colleague, Stefan Lautenschlager, who could do some FEA on the skulls, and then Larissa DeSantis in America, who could do dental wear. Mm-hmm. And we basically showed it doesn't have the same kind of stresses of the skulls as a Smilodon. And the tooth wear looks like it's eating really soft food, not eating hard meat, and certainly not cracking bone. So I think obviously it's a carnivore, but it sort of didn't have any of the attributes you would think it would need to be a real viable analog of a saber-tooth like cat or cat-like form like Smilodon or Barbara Felis. It just didn't. So,
So
anyway.
what do you think it might have been doing? What would you think it might have been feeding on?
What I think it did is the FEA, the finite element analysis, shows the skull and the canines are stronger in pullback than the head strike. So I think it used those big canines to open up the gut. And I think, and this is something that is controversial, and people don't like this idea, but I think it used a big tongue to slurp up innards. Because why would you lose the incisors? What's the reason for losing the incisors? The only time you see things that have lost incisors are animals who use their tongue for feeding, like walruses, or anteaters. I think a walrus is a better example, because everyone thinks of anteaters as having puny skulls, whereas a walrus has got a big, hefty skull. There's no other reason to lose the incisors, and it's got a rather domed palate, as do other animals, except today, who use their tongue for feeding. But I mean, that you can't prove. That you can't. There's no way of being able to really test that hypothesis. What you can show is it was not doing whatever something like Smilodon was doing. It was doing something different.
But this is a very interesting thing, isn't it? Because part of this whole question is to do with our ideas about convergent evolution and about making assumptions without testing them, isn't it?
Well, I think people often think that the other thing is not just convergent evolution. There's this sort of desire to sort of shoehorn extinct animals into a kind of known adaptations of known forms. Of course, I mean, one of the critiques we got back about these ideas was, well, nothing today does that. Well, duh. Nothing today is like an elephant. What would you think about an elephant if you only had its bones? Nothing today is like a giraffe. I mean, there are things around today that don't have analogous forms outside them. A couple of extant species. So people can be very resistant. People can be very resistant to the idea of an extinct form not being like anything today. But there are plenty of living forms that aren't like anything else either. So there you go.
It's an interesting trade-off, isn't it, between using modern analogues to understand the past, but also having to leave room for the possibility of exceptions.
Well, you can use modern analogues to see that something is not analogous. That's the whole what we did with Alex Milos. We did a lot of study with both, study of linear skull measurements, or actually no, there wasn't linear. It was more skull features, and then the finite element analysis, and then the dental wear. And it was by comparison with the living analogues, we could see that it wasn't like them. I know some people disagree with me. Steve Rowe in particular completely disagreed with this, but that's okay. That's his prerogative. But I think the other thing is people like their carnivores to be big and fierce. And they don't like it if you point out maybe this carnivore, wasn't a phrase my friend Dave Vostovsky coined, was more of a wuss than a puss. They don't like it. They want things to be bigger, badder, better, nastier. They don't like it. Someone's saying, well, maybe it wasn't that way. Maybe it wasn't the kind of fierce thing you paint it as being. Got a lot of flack from the paleo artist community for this. Oh, well, we know it did. No, we don't know what you drew it that way. You don't know. No one knows what it did, actually.
Oh, that's just so fascinating, and also a real conceptual challenge. And I must spend some time looking at the skeleton and trying to envisage this creature. A creature which, as we say, superficially at first you just immediately think but yeah, what exactly was it doing? That's quite fascinating.
Well, I mean, I used to give, when I was teaching at Brown, I used to give students a skull of a Chinese water deer in the practical. I had a lot of them tell me it was a saber-toothed cat.
Well, you mentioned earlier another group of animals that you're really passionate about, and that's kangaroos. So we actually, of course, the very first conversation I think you and I ever had was about sthenurines, wasn't it?
Yes.
Because it was when I was doing my master's degree in Bristol. and we were looking at projects for the Masters, and we talked about the possibility of a stenurine project, which we didn't end up doing. We did the carnivore ankle one. But I understand that you have since then worked with a student on the ankle of stenurines, haven't you? Well, let's reverse a little bit. We're talking about giant kangaroos. Tell us about what is a stenurine?
Okay, so stenurines were an extinct subfamily of kangaroos. So within the Macropodidae, which is the kangaroos apart from the rat kangaroos, the Macropodidae includes things like regular big kangaroos you see today, and also wallabies, tree kangaroos, pademelons, quokkas, lots of different kinds of animals. They are one subfamily, Macropodidae, and the stenurinae are another subfamily. And the split between them probably happened about 15 million years ago. That's when you see the first stenurine. And stenurines, they become more specialized for browsing than most kangaroos are. Although tree kangaroos are a bit convergent in their facial anatomy to stenurines. They get shorter snouts, shorter faces, more specialized kinds of teeth. But what's particularly interesting is in their back legs, at least by the Pliocene, they've lost the fifth toe, so they're only walking on one toe. And they get big. They are, in general, bigger than the Macropodies. The most famous stenurine is Procoptodon Goliath. It was about 250 kilograms, but that's not a typical one. Most of them were about the size or a bit bigger than a very big male red kangaroo.
So they get about sort of size of a human, don't they, or bigger?
Yes. So right? I mean, the average stenurine isn't that huge, though. The average stenurine is probably about 100 to 120 kilograms. But they're persistently larger. The modern large kangaroos today, they are actually unusual among the Macropodies. Most Macropodies are smaller. Things like pademelons and quokkas are most smaller bits. But the stenurines get big quite early on. They stay big. So the smallest stenurine is about 50 kilograms. That's about the size of a person, and about the size of your average red kangaroo, let's say. And the thing is that hopping, I was the person who first had a question whether or not they were too big to hop, particularly the ones that are very big. But hopping is a strange gait because you've got to do it in a crouched position. You think about how you would jump off your two legs. If you for a jump, you couldn't jump with straight legs. You have to crouch your knees and hips. And most animals, as they get bigger, they get a more upright limb posture for various reasons that relate to scales, weight scaling and support and everything else. And hoppers don't do this. So kangaroos, past about 50 kilograms, they're really out of a good size range for hopping. And it's been shown past about 150 kilograms, their hind leg tendons would snap. They wouldn't be able to support them. So there is the issue of how these big guys get around. But actually, I can tell you I can pinpoint the moment in time when I first got interested in stenurines. These are the kind of things you have these little sort of flashback memories of. I was in the Australian Museum in Sydney with Steve Rowe, my colleague Steve Rowe, in 2005, and we were looking at a mounted skeleton of Stenura sterlingi, which is one of the big ones. And I don't know where that skeleton has gone to now. It's not there anymore. But anyway, we were looking at it, and I looked at it and I said, that thing can't bloody hop. And part of my thinking that was because its lumbar region, the vertebrae, are all fused up. Uh-huh. It had no flexibility in the back at all. And I was told later, yeah, but that is a composite skeleton. I don't care. Those came from something. You know, I mean, you couldn't be a hopping kangaroo and have that abnormality. So how was this thing able to survive? So I started to think about, anyway, various reasons, looking more at their anatomy. I got an argument based on comparative anatomy with quite a lot of quantitative comparisons for them bearing weight on one leg at striding, bearing weight on one leg at a time. Certainly, rather than doing that kangaroo kind of slow locomotion on all fours or using the tail. And probably, at least in the bigger ones, as an alternative to hopping as well.
So you think it probably moved sort of generally day to day by walking, almost like a person, or did it ever hop?
Yes. I think the smaller ones probably could do some hopping, but the thing is, modern kangaroos have made their bones very gracile in order to stay hopping at that, modern big kangaroos, in order to stay hopping at that large size. And the analogy I always give about this is that we often think of these neurons as being very robust forms. But it's not so much that they are robust, it's that they're normal for a kangaroo of that size. It's the big kangaroos today that are very gracile. And the analogy here would be, if the only bigger cat you ever knew was a cheetah, you would think that jaguars looked ridiculously robust, but they're not, they're normal. So modern kangaroos are like cheetahs, and it's not just me who says this now, this has become a bit of a thing to say, which is good. Because they are very highly specialized for being able to hop fast. So if those smaller neurons could do any hopping, it wouldn't have been particularly fast hopping. It would have been clumsy hopping, a bit like a tree kangaroo hopping, if you've ever seen one of those do it. They don't hop. They can hop, but they don't do it very well. So I think they would have been able to do some hopping, especially the smaller ones. The very big, something like Triceratops Goliath, goodness, no, not at all. Most of the other ones, maybe they could do some. I don't know. It's hard to know. I mean, they're not around anymore, are they? But they don't have the anatomy like a modern kangaroo for doing rapid hopping. So in which case, why would they do it? And I also think that modern kangaroos are probably modified for long distance travel rather than escape from anything. What are they going to escape from? They're able to travel efficiently between bodies of water or places to eat. They are. It might be a fairly. My personal feeling is it's a fairly recent adaptation in the late Pleistocene. I just make the point of the idea that Seniorines walked bipedally, whatever else they did, but they did that. It has now been backed up by a trackway. Although this has only been published in an SCP abstract, so hopefully it'll be out at some point. But so people said to me, "Are you surprised?" No. I'm glad they found one. I'm not surprised. No. Because you look at their anatomy, they're clearly not able to do decent hopping, but they clearly are modified for bearing weight on one leg at a time. It's interesting you asking me about this today and about the projects at Bristol, because I had a project going, starting the year after you were there, with a woman called Amber Wagstaff, and then it continued with two other students in subsequent years, adding taxa to the mix. And finally, just working with her today on the page proofs of the final article.
Oh, that's great.
It's finally coming out. It's basically looking at second moment area of analysis of the bones, looking at stresses and comparing Seniorine kangaroos, actually 3 different kinds of Seniorines with 3 different kinds of macropodines, and showing that they had different kinds of locomotory stresses. That does not in itself prove they walked on the way I think they did, but it shows that they were doing something different. So it's finally coming out after years and years of work. Oh, goodness. That's good.
Well, so we're at the end of the questions I had written down. So I wondered if there was anything else that you would like to talk about to do with anything we've talked about, or any other subjects you think might be interesting to our Paleocast listeners.
Oh, goodness. Well, when I was drinking coffee just now, I was thinking more about what I was saying about trying to get a job when I was younger and stuff.
Mm.
It was such different times. I mean, I did see myself, I did see what I was doing as leading to something that we'd be teaching undergraduates. And of course, that's what I spent all my career at Brown doing. Thank God there are no more dogfish to dissect. I'll tell you that much. But that was what I think most of us in that cohort, we saw that's what we were going to do. We were going to go and teach. And times have changed so much since then. I don't know how to advise anybody anymore, how to go and get a career in this field. It's just not, it's completely different.
That's funny, because that was actually going to be my kind of final question to you, was going to be asking you really exactly that question. I was thinking about the sort of situation we're all in with the sort of ongoing coronavirus epidemic, which is obviously making things challenging on top of how challenging they may have already been. And I kind of wondered what advice you would give to people now getting on in paleontology.
Oh, I have no idea. I'm not, there are still people who want to go to grad school, and I still advise them and help them and write them letters. And I'm still thinking, well, I hope there's a career there for you when this is all over. I don't know.
Mm-hmm. How did you?
Well, I say to young people, obviously, I have a T-shirt somewhere that sums up a lot of my career that says I was under the impression that there was no maths involved. So obviously, take as many stats courses as you can, and I'm not. And now, of course, you can't do stuff without being proficient in R and everything else. And that, again, is so completely different. But from when I was growing up, although at the time I would have been able to take stats classes if I had wanted to, but I didn't want to. The stats class taught at university was at 9 o'clock in the morning on Saturdays, and I didn't get to it very often. But I didn't see it as being important. Of course, it's vital. You've got to be able to quantify what you do these days. And that's all good. I'm not saying it's bad, but it's just saying, yes, bear in mind now the field you're going into is a highly quantitative, highly technical one. And again, I can't give specific advice in that. I just say, get yourself a toolkit, learn the techniques you need to use for this. But don't forget that you still need to know your animals. So, my husband Jack, who was just at the start, Jack Sapkowski, who was just at the start of this whole technological revolution. And of course, he's famous as the person who computerized databases and did stuff on the computer and stuff. He would say to students, if you can't work it out first on the back of an envelope, then don't try and do it on the computer. And if you do, obviously with some of these things, you can't do highly technical things with pencil and paper. But if you can't figure out first sort of what results you're going to expect, then how will you know if you get a bum result?
Right.
I would love to tell my students, no, you've got to do it on pencil and paper. No, and they're going to say, they can't even buy graph paper anymore, but I wouldn't, back of an envelope, what's an envelope?
Letters for it.
But if you don't have some kind of idea first about what your result's going to be, it's all the quantification in the world isn't going to help you.
So why are you asking the question, in other words? Yeah.
And what worries me right now is that it's been getting more and more difficult for people to go to collections and actually see bones of themselves. And now it's impossible. And you really can't get that same information. You can get some information by looking at images on the internet, but it's nothing beats being able to actually go and hold things and rotate them and look from different angles and just get, when it's possible to go back to the collections, I would really advise everybody to do as much as you can. It's harder now because now you haven't got free reign anymore in collections. You've only got access to certain cabinets that are locked for you. When I was working at the American Museum in New York, well, for example, as a grad student, I was lucky to have friends in town so I could stay nearby. And there was no limit to how long you could stay there. And the cabinets weren't locked. So I would stay until 10, 11 at night, just going through, opening all the cabinets, looking at everything. And that's how I think I got a lot of my understanding of what it's all about.
Well, I did notice in almost everything we talked about here, it almost always started with a story of you being in a collection and looking at something and saying, hang on a minute. Yeah.
Yes. Although one time I'd stayed late at the American Museum and the only way to get out was going past the T-Rex skeleton in the dark. That was really scary.
I also remember as a student, you always talking to me and drilling into me and to your other students about the importance of actually becoming familiar with the animals that you're studying, and that all the computation in the world, won't help you if you don't actually know what the bones look like. And I never forget that. I always think, hang on a minute, have I spent time just looking at everything before I start down this road? It's one of the best bits of advice you gave me, definitely.
Thank you. Well, I'm glad you took that to heart. But nowadays, people can't get access to specimens, and so they're being told, oh, well, you can get all these data from photographs. And you can get data from photographs, yes, but can you get the same appreciation of what's going on? Not really. So I would really advise people when they can. And the thing is, of course, to go into collections takes time, it's inconvenient, it takes money to go on the bus or train somewhere and stay somewhere, and there are often no funds for that. I appreciate that, but it's still invaluable. The other thing I think I say to students is read the literature. You're meant to be interested in this topic. Make sure you read all the current journals, not just stuff that is assigned to you. Read around things as much as you can. There's lots of stuff out there, and I'm sure your advisors will give you reading lists. But, don't skimp on doing that. And you don't have to understand everything that's being done to get a feeling of what the paper is all about, and get a feeling for the information that they're finding out and the techniques they're using and the questions they're asking. I find a lot of students these days don't read apart from things they're told to read for an assignment. I say, well, that's crazy. Read all you can,
Yeah, you never know also what you're going to kind of come across in a paper that will get you thinking about a research question, I guess.
Exactly, yeah.
Well, it's been an absolute pleasure talking to you, as always. And I'm really looking forward to some of the research you were just talking about there that's coming out in the next, I was going to say the next few years, but hopefully this year, maybe.
Next few weeks, if it's in page proofs right now, my goodness. I'll send you a copy when it comes out.
Fantastic. And we'll put a link to it in the episode information online.
Okay.
Well, thanks again, Christine, and take care.
Okay, thanks, Alison. Bye-bye.
PaleoCast was brought to you by Dave Marshall and Liz Martin Silverstone, with contributions from Tom Fletcher, Vish Venkat, and Elsa Panciaroli. Music was composed by Patrick Kendall Smith. PaleoCast was made possible by funding from the Palaeontological Society and the Palaeontological Association, but the show now relies on funding from you, the listeners. So, if you've liked this episode, please consider donating, and thanks to everyone that's helped out so far. Please visit paleocast.com for the supplementary material to this episode and for our archive of past programs, and follow us across social media platforms to get all the latest news. Finally, if you enjoy our podcast, then please explore all of our video content on YouTube and follow our other projects, the Virtual Natural History Museum and the PaleoCast Gaming Network.